The next speaker is Mausam. So Mausam kind of has a split personality. So he does a lot of work in NLP, and he also does a lot of work in planning and, as he puts it here, sequential decision making and uncertainty. And before joining IIT Delhi again, he was faculty in University of Washington, and so he has this habit of staying on as faculty in institutes where he got his degree. So he got his PhD from University of Washington, as well as got his undergrad from IIT Delhi. So,
and I need somebody to help me figure out where the presentation is.
Your clock has started ticking down.
Apparently. Well, thank you very much, Ravi, for the introduction. Thank you very much, Google, for giving me the opportunity to come here and talk to you about my work. I was given 10 minutes. I could spend 10 minutes just chit-chatting, or I could spend 10 minutes talking about one piece of work. I had to make a call, so I decided I'll at least tell you about something. So this is our latest work that I actually know nothing about dialogue before this piece of work. Dialogue has become very hot, so I guess it's the right time to be working in this area. So my student was very interested in it. So I thought, okay, we'll learn. Dinesh Raghu is the PhD student on this particular project, and he's a employee of IBM. Again, another reference to IBM. He's a part-time PhD student at IIT Delhi. Nikhil is the other undergrad. Before I start, this is what I do for the living, or most of my living. Actually, decision-making and stuff is taking less and less of a seat in my research portfolio. Ravi is beating me to that game. So this is what I mostly do in my research life. I have knowledge base in the middle. Anything and everything that gets done when you have knowledge in the middle, that is what I'm interested in. So it could be extracting information from text and putting it into knowledge base. It will be taking the knowledge base and completing it using more inference, understanding knowledge base, providing the missing links. It is using the knowledge base for applications that a person will see, using the knowledge base for an application that a machine will see. Okay. So let's talk about dialogue systems. But again, since I work in a knowledge base centric view, it has to be a dialogue system with knowledge base in the mix, right? Not surprising. And this is the kind of, so when does a dialogue system need to work with a knowledge base? Whenever it needs to bring in knowledge or information from the knowledge base and use that in conversation. So here is a sample conversation. Forget these two ones. They should not have been there. Good morning. What can I help you with? The user says, I want to book a table in Bombay. It's a restaurant reservation system. So the user system knows what's about it. It says, the system asks what kind of cuisine. The user says Spanish cuisine, how many people, and so on and so forth. From this, once the user says, forget again these two, when the system asks which price range you are looking for, the user says in a moderate price range, please. At this point, I want to build a system, in this case, a memory network, which is going to output the fact that now it has all the information that the user has given, that it needs to figure out what are the possible restaurants it can recommend. So it is going to make a knowledge-based call. And for the city, Bombay, cuisine Spanish, price level moderate, and it will then get all this information. Now, once it gets all this information, let's say it knows about El Toro Cafe, it knows about Escobar Tapas and many other restaurants which are in Bombay on Spanish cuisine. Then the user says, can you book a table for me? Then system says, yeah, sure. What do you think about El Toro Cafe? And for some reason, if the user says, nah, it's too far, I'm not interested in this, then its memory network should figure out the next restaurant to recommend. So this is my problem. I want to design this neural network, which takes in all this information, the conversation so far, the database results, and then finally output the next response. And people have studied it in many contexts. One is the baby dialogue system, which was released by Facebook AI Research. It has a set of restaurants in the knowledge base. Each restaurant has name, cuisine, price range, etc. in its knowledge base. And then there are many tasks that they have defined. One set of tasks are to gather user choices and generate API calls. One set of tasks are to display all the options available and provide information about the options. And notice this task 3 is actually the hardest task, and we'll talk about why. And then you can have a task which is all combined. So this is a toy setting, but the goal is to make this one neural network which can solve all these tasks without any domain-specific knowledge, so that we know that the neural network, which neural network has the capability of doing this conversation, and then we can take the next leap from there. Okay, this is where we started. This is the accuracy of existing systems on the 5 tasks. And we thought, It is not doing very well for task 3 and task 4. So let us focus on that. And I have only one way of focusing on the problem, look at the data. But of course, people want to build, my students wanted to, add this architecture and make this change and make that change. I said, let's look at the data. Let's see what's the problem. So imagine that in your knowledge base, you have restaurants, El Toro Cafe, Escobar Tapas, Valhalla, the Third House, all restaurants serving Spanish cuisine in Bombay. And you want to say, okay, since you don't like El Toro Cafe, what do you think of Escobar Tapas? This is what you want to predict from a neural network. In fact, my neural network predicted, what do you think about this option, Sarvana Bhavan? And it made no sense to us. Sarvana Bhavan is not even in Bombay. And it's definitely not serving Spanish cuisine unless, I don't know, for something. So we were very stumped what is going on. And then we realized, what is happening is that it has some restaurants in its training set. And it only has the ability to recommend those restaurants that it has seen at the training time. Well, of course, knowledge base is a huge thing. It would not show all its data at training time. So you need to learn to generalize that whatever information I am getting in my knowledge base, that is the information I need to use in recommending restaurants. But of course, the neural network did not have that ability at the time. So our work basically creates a slightly complicated network, which we call hierarchical pointer memory network. It's a novel architecture to tackle the OOV issue. It uses a memory network encoder with a specific kind of memory and a sequence decoder which not only generates a word from its vocabulary, but can also copy a word from the memory and return it. Okay, and for that we also ended up developing the hierarchical attention, which gives us a couple of more points. Now we have no time to really go through this architecture, so I'm just going to skip it. But before I skip, I wanted to say two things that are interesting. One, my memory is now in this fashion. This is a hierarchical memory. Each row is an utterance, and each column is a word inside the utterance. So for example, hello, what can I help you with today? This whole thing is one utterance. And then I also have representations for each individual words. Why do I need this? Because I want the ability to go to one specific word, pick it out, and output it in my conversation. So therefore, I need to have a representation for each individual word. And you can, if you know this stuff, you can quickly do this. You have an LSTM within the utterance, and then you can do an utterance representation from there. Okay, I'm going to skip all of this stuff. This is standard memory network business. And then we have a sequence decoder. And the decoder has the ability to not only generate a word from the vocabulary, but also do some attention over each individual word. And so, sorry, this is at the sentence level. So let me skip this. This is the generation. So you can always generate from its distribution, but that's not enough because we need to handle the OOVs. So for OOVs, we allow the possibility of copying from the memory. And for that, we need to have a system which we call a pointer decoder. So pointer decoder generates a word from its decode vocabulary, which it had seen at training time, also can copy a word from the memory. So it needs to have a generate distribution and a copy distribution, and then it needs to do the combination. And so you have a word level attention and a combined distribution, which says with some probability you generate, and this is your generate distribution, and with the remaining probability you copy, and this is your word level attention. And we in fact do some even one step further, we do hierarchical attention. So we have an utterance level attention and a word level attention, and you multiply the two to get the final word level attention. So this is a final architecture. As I said, it's fairly complicated, but actually the main piece that we have added is this piece, okay, and this piece. Everything else was the older memory network, plus and minus. But how well does it do? So the first column is us, and it's actually doing better than I expected it to do. So on this nicer setting, it gets, basically it solves most of the tasks. Now, there is a non-nice setting of the data set also, where it is not solving all the tasks, it is doing slightly worse. So we need to keep doing, but actually we ended up solving more or less the problem we started out by solving. So let's look at the task 3 carefully. I need to recommend a restaurant. So I want to make sure I recommend a restaurant only from the knowledge base. I do not suggest a previously suggested restaurant, and I sort the previously unsuggested restaurants based on rating and suggest the best next restaurant. This is sort of what we want the neural network to learn by itself, right? We are not giving this information. And so we created 2 task-specific metrics. One was, am I recommending something from the knowledge base? 1 minute. So so it will say yes, even if I had said Valhalla, but it will say no if it's server number 1. And then how often are we recommending the correct restaurant? And we exactly found that our network is always suggesting a restaurant from its knowledge base. And notice the memory network from Facebook and many other networks never ever suggested a single restaurant from the knowledge base. They were always doing server number 1, which made no sense to me whatsoever. And we are still recommending the best restaurant 80% of the time, so we have some place to go. And this particular slide shows that actually hierarchical attention does better than non-hierarchical attention, but that's okay. That's a detail. So this is our contribution. When we do NLP, it is important to look at OOV problem. A lot of early architectures have sort of sidestepped the issue, and this is dealing the OOV issue in the context of dialogue with the knowledge base in the mix. Whenever I get knowledge base results, they can be OOV. We need the ability to point to them and use them in conversation, and hierarchical generative memory networks helps you. I'll stop here.